This is our study guide for chapter 4. And the first question says use mapping choose the mapping that represents the relation and determine whether the relation is a function. I would think that this is how you would go about it, that you would look at these numbers, and the first thing that you would decide is that, yes, it's a function. Once you decide that, then I would look at my 4 answer choices, and I would eliminate the ones that obviously are wrong. Now, the reason I said it is a function is because the x values are not repeated. That's what you use to determine it. So the first one says the relation is not a function. That's not right. So I'm going to mark through that one. I don't have to worry about that one at all. The second one says it's a function, and so does this one. So this last one says not a function. I'll mark it out. I've eliminated my answer choices from 4 down to 2. Now I want to choose the one that correctly maps the x values to the y values. And you notice in this problem that all the y values are -6. That is perfectly fine. You can repeat that in the y values all day long. You need to put the x values in the first oval and the y values in the second. So our answer here is B. Question 2. Question 2. Now, you didn't have to do all of these for homework, so you'll just be copying along as we go. But it says to evaluate f of x equals -4x minus 3 for x equals -3. That means take that -3 and it goes in place of x. F of -3 equals -4 times -3 minus 3. Function notation is what sits out front. That f of x and that f of -3, it doesn't mean anything mathematical. You don't do anything with the f and the -3. Your math problem is over here. And when you multiply -4 times -3, you get 12. And 12 minus 3 is 9. So that is the answer for number 2. Number 3 says a taxi company charges passengers $1.25 for a ride, no matter how long the ride is, and an additional 25 cents for each mile. This rule, they're going to give you the rule, C equals 0.25 m plus 1.25 describes the relationship between the number of miles and the total cost. What is the charge for a 1-mile ride? That means you take that formula and you put 1 in place of m and you work it out. So it's like 25 cents plus $1.25. So that answer is going to be $1.50. The second question says, how much for a 2.7 mile ride? So it's 25 cents times 2.7 plus $1.25. Now I would do that on my calculator. I would enter the entire problem. 0.25 times 2.7 plus $1.25. And that price is 1.925, but because it is money, it's going to round to $1.93. They're going to round up for money. $1.93. Number 4 says graph this function y equals -4x plus 3. So we need to do that on graph paper. Let me pause. Huh? I thought maybe on the back I had a graph, but I don't. I can graph some. So this is what it's going to look like. Y equals -4x plus 3. You need to make a table. You get to pick 3 numbers. Pick 3 numbers. Make them easy to use, like -1, 0, and 1. So it's going to be -4 times -1 plus 3. Yes, ma'am. And when you do -4 times -1, you get 4. And 4 plus 3 is 7. And then -4. Can you hand her, did somebody help? Hand her a piece of graph paper. Thank y'all. -4 times 0 is 0. 0 plus 3 is 3. Our last one, -4 times 1 is -4, plus 3 is -1. And then we'll graph. -1, I'm sorry, what? That's a total. -1, 1, 2, 3, 4, 5, 6, 7, right there. Can y'all see that? 0, 3, and 1, -1. Now, what's the matter? You get to choose these. I would choose numbers that are fairly small, so you don't use so much graph paper. You could. You could use -2, 0, and 2. You got to use at least one negative. At least one negative. Now, is this linear? Yes. Okay. Okay. Question 5 says, y equals absolute value of x minus 1. You're making a table and a graph in this one too. You get to pick. I'm going to choose the same ones I chose that time. So I'm going to have the absolute value of -1 minus 1. Absolute value of -1 is 1. Remember, absolute value produces a positive answer every time. So it's 1 minus 1 is 0. Absolute value of 0 minus 1 is -1. 0 minus 1 is going to give me -1. Absolute value of 1 minus 1. That's going to be a 1 again. Take that 1 away. Going to get 0. When I graph this one, -1, 0, 0, -1, and 1, 0. What happens? V-shaped. So it's not linear. Okay? Number 6. Write a function rule for the table. You need to look across and decide what are they doing to turn -1 into 4, 0 into 0, 1 into -4, and 2 into -8. Do you think they're adding, subtracting, multiplying, or dividing? What do you think they're doing to x? How could you change -1 into 4? You could add 5 or multiply by -4. The 0 is not going to help me because it's when you multiply by 0, it doesn't matter. You're always going to get 0. Let's move to 1. 1 changed into -4. You could add -5 or you could multiply by -4. 2 changed into -8. You could subtract 10 or you could multiply by -4. What are they doing each time? So it's going to be f of x equals the x value multiplied by -4. I would write it this way. Number 7. What are we doing to change 1 into -3, 2 into -2, 3 into -1, and 4 into 0? What are they subtracting? You think they're subtracting 2? What did you say, Jaylee? 4? Will that work every time? Will they be able to, was 1 minus 4 going to be negative 3? Is 2 minus 4 going to be negative 2? Okay, it works every time. Number 8, write a function rule that gives the total cost, C of P, of P pounds of sugar if each pound is 35 cents. What do you think we should write for this one? Going to start with C of P. If the sugar is 35 cents a pound, what are you going to do to determine the cost? You multiply the 35 cents times the number of pounds. All you have to do is write that rule. That's all you have to do. They don't ask you to do any math. They just ask you to translate that. No, it's 0.35 because it's money. Use inductive reasoning to describe the pattern. Then find the next two numbers. Okay, so we're going to put minus 4. What will the next number be? And then 10. Graph the relation. Use the vertical line test to determine if it's a function. So you're back to your graph paper. Draw you a grid. You need something? Okay. Negative 2, 3 is your first point. 1, 5. Next point. Did I get that right? Negative 2, 3. 1, 5. 3, 1. 4, 5. Now, all we've done is put the dots on there. I usually ask you if it's linear. Obviously, it's not linear. But the question they want you to answer is this a function? How do you know? How do you tell? Mel? No x value is repeated. If you were to take a vertical line and slide it across, it would only touch one dot at a time. If it touched two dots, because those two dots were stacked above one another, it would not be a function. That's how you test it. Okay? 11, this is 10. 11 says, write a rule for the linear function in the table. 2 into 6, 4 into 8, 6 is changed into 10, and 8 is changed into 12. What do you think they're doing to make those changes? Okay, so f of x equals x plus 4. Number 12, label each section of the graph. This is speed and time. Guys, this is how fast somebody's going. It is not their height and it is not their distance. At the beginning of this story, was this person standing still or was this person already moving? Already moving because the speed is not down there at 0. What happens to the speed here? Down. So put a 1 right there and over here put speed decreased. Okay, what happens in this section I'm going to call section 2? Good. Tell me about the peak. That's well, it really doesn't stop, but that's the fastest. That's the highest point on the graph, so that's the fastest they're going right there. Okay, now what about right here? Okay, the speed decreased. What about section 5? It looks flat, but does that mean they're stopped? steady pace. So I'm going to put cruise control. That's how I would do that. Then you've talked about each different thing that's going on in the problem. It says it's the fastest because it's the highest point on the graph. Yeah. Put it neutral. Yeah. But you're going to make sure you know you're going the same. 13 says model this with the table of values. When you put -1 in place of x, we're going to get 3, and 3 minus 1 is 2. When I put 0 in, 0 minus 1 is -1. When I put 1 in, it's going to be -4. And then I graph it. -1, 2, 0, -1, 1, -4. Linear. I don't think it really asks you that question, but I'm glad that you know that that one is linear. Sorry. You good? Okay. Next page. Elaine is in the business of repairing home computers. She charges a base fee of $35 for each visit and $40 per hour for her labor. The total cost for a home visit and X hours of labor is modeled by this function rule. Use the function rule to make a table of values. Okay, I'm going to show you a different method to do that. I want everybody to take their calculator and I want you to turn it on. It's the disinfectant. And I want you to press Y equals over here at the top left-hand corner, and I want you to press clear. When you get to this screen, lay it down for a second so I know, and then I'll move on. Okay. Y equals is what you press, and you clear it out. Now type this in, 35 plus 40, and then here's the X button. It's right underneath the word mode. Type in 35 plus 40x, and the X button is right under the word mode. Not yet. I just want to make sure everybody's caught up with me before I move on. We're not looking at the graph. We're going to look at the table. So I want you to watch these keys. You're going to press the blue button and then the graph button, and it's going to take you to the table. Please raise your hand when yours looks like this. Good, good. This is, I've got too many, I cannot understand 5 people at one time. These are the buttons. If you're sitting here, you press second graph to take you to the table. Now, you can move around. If you're underneath X, move around until your table has the numbers on it that we need. And record your values. What's the first one? 35, and then what? 75, and then what? And 155. Okay. So when we go to graph this, it's talking about hours and cost. Now, hours needs to be 0, 1, 2, 3. Cost needs to be counted by something other than 1. I need to get up to 155. 20s, 40, 60, 80, 100, 120, 140, 160. I think that's far enough. So for 0, it's going to be 35, which is close to 40, but not quite. For 1, it's going to be 75, which is close to 80, but not quite. For 2, it's going to be 115, which is almost to 120. And for 3, it's going to be 155. Okay, so we have graphed this data. Okay. Yes, it does appear to be linear. Number 15 says find the range. Guys, that's the y values. Let's do that on our calculator. Go back to y equals and clear that equation out. Type in the equation that you see here. 3x minus 5. With me? Go to the table. Press second graph to get to the table. Now, you want to know the y values associated with this little group of numbers right here. So go to negative 2. What's the y value for that? Negative 11. Right here. You with me? The next one's negative 1. What's its y value? And then 1. What's its y value? And then 2. What's its y value? 1. Okay, so we have found the range. Question? Which one are you asking me about? This one right here? Okay, you got it? Number 16, use the vertical line test. So you're just going to slide your pencil across. If your pencil touches 2 dots at the same time, because they would be vertically stacked, the answer would be no. That doesn't happen, so the answer here is yes, it's a function. What about number 17? No, I'm going to circle the 2 dots that cause it to fail as a function. Bless you. 18 asks you to identify the domain and the range. So you're just going to tell me the domain members from the list. When you're looking for domain, it's the x values. Jaylee? When you're looking for range, you're looking for the y values. Landon? Then that's all you put in there. You don't have to list it over and over. You just put it in there one time. Okay? Everybody caught up on 18? '19. Sketch the graph of the speed of a bus on a daily route. Label the section. The bus pulls away from a stop. Guys, if it's stopped, how fast is it going? 0. So the story starts right here. And it increases speed. So what am I going to do for this section? Up. The bus is at a constant speed between stops. So it's going to be flat. So this is part A. This is part B. The bus is stopped. And it stops right here at C. I mean, it had to slow down, right? I mean, it might have been really fast slowing down, but it had to slow down. The bus increases speed after stopping. So it stopped. So this would be D. Last one. Number 20. This table shows how much a carpenter charges for work. Is this linear? Explain your reasoning. Guys, how much does this go up each time? I think you're right. 15. You're correct. So to be linear, where's my word linear at? Over there. It must have the same ratio of change. So it's every hour, it's not going up the same. So the answer here is no.